Okay, so I'm going to show you some of the strategies that we have been talking about. I'm going to show you how they apply to some of the problems on this paper, to some of the more challenging problems that we're going to see, so that you can see how these strategies can make these problems easier for you to do. So I'm going to skip 14 because I am confident that you can do 14 on your own from what we talked about. So let's go and look at 15. And if you see, we have 5/11 and we have 1/2. Okay. So back in the first video, I had talked to you about the fact that 5/10 is equal to 1/2. 5/10 is pretty close to 5/11. So that's why I am looking at 5/10. And if you think about 5/11 and 5/10 and you try to compare the two of them, we can now look at their denominators, because when two fractions have the same numerator, since they both have a 5 in the numerator, we can look at the denominator to help us decide which one is greater. And remember, I said that when the denominator is larger, it means that you have cut that fraction into smaller pieces. So each piece is smaller. In the case of 5/11, the pieces are each smaller than in 5/10. And so those 5 pieces in 5/11 are going to be smaller than the 5 pieces in 5/10. So that tells me that 5/11 is less than 5/10. And since 5/10 is equivalent to 1/2, 5/11 has to be less than 1/2. Okay, so now we're going to look at problem number 16. And just like in number 15, we already know that 5/11 is less than 1/2. So that's going to help us in problem 16. We already know that 5/11 is less than 1/2. So in problem 16, we have 7/12 and we have 5/11. Now, let's see if you can figure out how many 12ths would be equivalent to 1/2. I'm going to pause here and I'm going to see if you can decide what would go there. How many 12ths would be equivalent to 1/2? Another way to look at it would be, what is half of 12? If you guessed 6/12 is equivalent to 1/2, and you are correct. So if we know that 6/12 is equivalent to 1/2, then think about what that tells you about 7/12. Think about whether that's greater than 1/2 or less than 1/2. And since I got you started by telling you that 6/12 is equivalent to 1/2, I think you can figure out what that tells us about 7/12. And I think now you should be able to compare these two fractions, because remember, we already know that 5/11 is less than 1/2, because we learned that in the previous problem. Sorry, the light is kind of glaring. Okay, so we already know that. I think that you have everything you need to figure out problem 16. I'm not going to give everything to you. I want to see if you can figure this out, because I know that you can do it using the strategies that I just showed you. All right, so now, if you need to pause the video so that you can work through those problems and take a little bit more time to figure them out, go for it. And then I'm going to move on to the bottom, and we're going to order the fractions on the bottom from greatest to least. I'm not going to do all of these, but we're going to do a couple together. I'm going to let you try 17 on your own, because they all have the same denominator. And I don't think I need to give you any more tips on that one. So let's look at number 18. We have 2/3, 5/6, and 4/10. Okay. Now, we need to order them from greatest to least. So we need to figure out which one is the greatest and which one is the least. Let's think about our benchmark fractions. So let's think about 1/2. And let's figure out if any of these fractions are greater than 1/2 or less than 1/2. So I know that 3/6 would be equivalent to 1/2. So that tells me that 5/6 has to be greater than 1/2. And over here, I know that 5/10 is equivalent to 1/2. So that tells me that 4/10 has to be less than 1/2. So if this is greater than 1/2 and this is less than 1/2, I already know that this fraction is going to come before this one when I put these in order. But now I have to figure out what to do with this one. So now I really need to see which one is going to be greater between these two fractions, because we know that this one's going to be the least. So now we have 2/3 and we have 5/6. So we have to compare the two. Now, I'm going to draw a model to help you see this one, because this one is a little more challenging to do because we can't use 1/2 as a benchmark fraction to help us with 2/3. So I'm going to draw a picture. And I'm going to draw a model for both fractions. I'm going to draw 2/3 and I'm going to draw 5/6. Here's 2/3, or I'm sorry, here's a fraction broken up into thirds, and I've shaded in 2 of them. Okay. This one, I'm going to break it up into thirds first, and then I'm going to break each of those in half to break this fraction into sixths. 1, 2, 3, 4, 5, 6. Now I'm going to shade in 5/6. So now, this picture model helps me to more easily see which fraction is greater. This is 2/3. This is 5/6. Clearly, 5/6 has more shaded in than 2/3. So that fraction is greater than 2/3. So I can now put these in order. 5/6 becomes my greatest fraction, followed by 2/3. And then lastly, I have 4/10. Just like that. All right. So now, let's take a look at one more of these problems on the bottom where we have to put the fractions in order from greatest to least. Let's look at, we're going to look at number 19 together. So we have 1/3, 1/2, and 3/4. Okay. Now, 1/2, that's our benchmark fraction, so that one's pretty easy to figure out. We need to see whether 1/3 is greater than that or less than that, and then we also need to figure out if 3/4 is greater than 1/2 or less than 1/2. So let's look at 1/3. And remember, I told you that whenever the numerators are the same, you can just look at the denominators. Because when you have a pie broken apart into more pieces, like in this situation, each piece is going to be smaller than when it's broken into less pieces. So one of these 3 pieces is going to be less than one of these 2 pieces. So 1/3 is less than 1/2, which means that 1/2 is greater than 1/3. But now we need to figure out where 3/4 fits in. So when I think about 3/4 and I compare it to the benchmark fraction, I know that 2/4 is equivalent to 1/2. And 3/4 is greater than that. So that tells me that 3/4 is greater than 1/2. So I can put these in order. 3/4 would be the greatest fraction. 1/2 comes next. and then 1/3 comes last. Because remember, when you're looking at these two, in 1/2, your pie is only cut in half, is only cut into 2 pieces. So that piece that you're going to eat is bigger. In this pie, it is cut into 3 pieces. So the piece that you're going to get is smaller because it's cut into more pieces. Okay. So I want you to try the other ones on your own that we have not reviewed, and I want you to use some of the strategies that I've shown you. These can be challenging, but as long as you stop and think about benchmark fractions, think about the value of the pieces when you have bigger denominators versus, the size of the pieces when you have bigger denominators versus smaller denominators. And draw models when you need to help as well, because sometimes drawing pictures, fraction models can also help you figure out which is greater and which is less. Good luck. You can do this.